Yeah, this is an empty room. We're going to start our review for the AP test. So I don't know how much you have looked at this or have gotten started with it, but on Schoology, I have this folder under the About This Course page called AP Test Review Materials. Have you looked at this at all?
Not really.
Okay. So what we should familiarize ourselves with at the very least. First off, I know I've done this a couple times, but we have our formula sheet. Mm-hmm. So just at a glance, X bar, mean, Y hat, linear regression, R, which we will most likely be given, or use our calculator to calculate, is 1 over n minus 1, the sum of the z-scores for the x and then the z-scores of the y's multiplied together. That's what it came from. Then we have our standard deviation, which is the square root of our variance. And then variance, if you forgot, is the sum of all of the residuals squared over n minus 1. A couple other things. How do you find slope? How do you find y-intercept for a line of best fit? Slope is the correlation coefficient times standard deviation of y divided by standard deviation of x. And then to find the y-intercept, we usually use y bar equals, or the average y value is equal to a, which is the y-intercept, plus the slope times the average x value. So far, that's about what we'll need for the first 2 units. So I'm going to pull those up. Of course, these are all optional. I'm not going to make you turn these in. So why don't we go to the first unit? Just give it a quick glance. So from College Board's perspective, Unit 1 is about the basics of statistics. So variables, categorical variables, quantitative variables, describing quantitative variables and their graphs and charts, finding summary statistics, graphical representations, and the like, comparing distributions, and then the normal distribution. So these are the standards. I have 2 AP questions from AP Classroom that we're going to go over. So if you want to get those loaded up, that'd be great. Otherwise, I will just go ahead and look at these. You can ask questions as we go, but we'll just kind of go one at a time. Sound good?
Yeah, I pulled it up right now.
Perfect. Okay. So indicate clearly the methods you use because you'll be scored on the correctness of your methods as well as the accuracy and completeness of your results. The manager of a vacation resort believes that the ages of adult visitors to the resort can be modeled by a normal distribution. The manager surveyed a random sample of 765 visitors and recorded their age. A summary of the responses is shown in the frequency table where X represents the age of the visitor. Construct a histogram of the distribution of ages. Okay, so I need a new document and then we'll do a split screen of this. So first thing, let's get this. Couple things that you will want to have on your histogram. First is a title. Easy points. That you could miss. And so we will have age and we will have frequency. Other ones that we probably want to have is equal spacing. So this will be 20 to 30. This will be 30 to 40, 40 to 50, 50 to 60, 60 to 70, and 70 to 80. Probably be not great if you had someone older than 80. over 80 years old going to your vacation resort. Okay, then I see that our totals are kind of by 25s. So we'll go 25, 50, 75, 100, 125, 150, 175. Sound good?
Yeah.
Okay. I'll try to do this in a couple colors. 20 to 30, 160. So we want all of our bars to be roughly the same size in terms of its width. 30 to 40 is 130. 40 to 50 is 100. Love that one. 50 to 60, 115. Zoom out a little bit so I can see. Should be slightly higher. 60 to 70, 125. I have that one slightly higher than that. 70 to 80, 135. So slightly higher than that. Okay. Is there anything missing from my distribution? I labeled my x-axis and my y-axis. I have roughly the same bin size, so I can compare the distribution. And I have a title. So anyone looking at this can know exactly what we're talking about here. Write a few sentences to describe the distribution of ages of adult visitors to the resort. Okay. What would you say this distribution is?
Before that, would it matter if I don't say like years for age? Like give it a unit.
Good point. We should probably give it a unit.
Okay. Would there be a unit for frequency?
No, because frequency is just a count.
Yeah.
The only other way you could think about doing this, and I don't think it would be a good display of it, would be a relative frequency chart. So coming up with the percentages of each group. But then again, we're losing the data by doing that. But you're right. We would need that unit.
Okay. So we can say it's uniform. Well, it looks uniform and symmetric.
So I would say roughly symmetric. So because it's not unimodal, I probably don't want to talk about the mean, but I'd rather talk about the median for my distribution. So the median, I would say, is roughly between 40 and 50 years old.
Yeah.
Just from an eyeball. What else should we talk about?
There's no outliers.
No outliers. We do want to talk about the spread, but we talk about the spread. So the range of ages.
It's evenly spread up.
I mean, we could say evenly spread out, but like, what's the minimum age?
20.
The adult ages vary from a minimum of 20 to 30 to a maximum of 70 to 80. Which would then mean, so the range of ages, well, if we took the lower bounds, if you said 70 to 30, the range of ages would be between 40 years old and Well, what if we did the two high numbers, 20 to 80? That would be 60 years old. That makes sense?
Yeah.
I don't see any gaps. I don't see any outliers. So and you already no outliers. I should probably say visible. Just because we have such chunks in the age groups, I can't really tell if there's outliers, but from our graph, none.
So why did you talk about the range instead of the spread?
Well, that is, I mean, so what are the two ways we can talk about spread? How far the values are apart? So if it was symmetric, I'd like to talk about standard deviation. I always want to bring up the highest and lowest numbers to give how far everything is apart. But in this case, because it's not unimodal, I'd rather talk about the range. I mean, you could probably talk about the IQR, but that also you had to do a little bit of work. So just from this distribution, the easiest spread metric would be the range.
We can talk about the mean, can't we?
You could, but also, is it a good descriptor of the data here?
I mean, and if you had it, yeah.
But so again, we use mean and standard deviation when it looks normal, when it is roughly symmetric and unimodal. We are better off if the data is skewed or not unimodal or has gaps or outliers of using the median. So this picture, as we drew, because it's inverted, it's an inverted normal, it would be a better descriptor to use median as the measure of the center.
Okay.
Because you can see if the mean would probably be lower than the median here. Because we have far more young people, which is shifting the mean lower.
Okay.
How about the last one? Does the histogram provide convincing evidence that the surveyed ages come from a normal distribution? Okay, so what should we see from a normal distribution, and what are we seeing? So a normal distribution is unimodal and symmetric. In the histogram above, in our histogram, I spelled that wrong, histogram. Values from the mean, so like the ends, higher, actually the youngest people and the oldest people are more frequent. So young vacationers, to add context, 20 to 30, and older vacationers,
70 to 80.
70 to 80, are more frequent. Which is likely, squishy word there, not
Unimodal.
yeah, I was gonna say just a normal distribution. So you see how I made a claim, a normal distribution is unimodal and symmetric. While our data is symmetric, because the symmetry is from the ends, it's not gonna be normal.
Could a bimodal be like the two peaks are at the very end and beginning?
Sure.
Okay, I'm just asking.
Bimodal is just saying how many peaks you have, not necessarily where they are, just how many. So it doesn't matter if you had the ends or two separate groups, like we saw with the other question before.
Mhm.
So that was question one, histogram.
That's an
Not too
FRQ
bad.
question.
I mean, this is from all of these questions that I'm pulling that we'll do this week are from AP Classroom. So yeah, these are the types of questions. Now, probably a little more involved on the AP test rather than unit specific questions, but I'm trying to give you the gist of what we want to be able to do. Okay, so let's go to unit 1, question 2. And then I will still have, should probably just kept this up. So question 2. A certain type of bird lives in 2 regions of a state. Let's say the lower peninsula and the upper peninsula. The distribution of weight for birds of this type in the northern region is approximately normal with a mean of 10 ounces. Okay, so mean 1 is 10. Standard deviation of 1 is 3. The distribution of weight for, let's say northern, say N. Distribution of weight for the southern is approximately normal with a mean of 16 ounces and a standard deviation of 2.5. Okay, so that's our information we're given. Because this is early unit stuff, it's just going to be the basics. I could probably push you on this a little bit further to compare these two distributions, but this one's going to say what? Calculate the z-scores for a weight of 13 ounces living in the northern region and for a 13 ounces bird living in southern region. Okay, so this goes to z-scores. Let's make that smaller. To calculate a z-score, it is our value minus the mean over the standard deviation. Z-scores are saying how far are we away from the middle with the standard deviation being our ruler. So for the northern region, that would be 13 minus 10 over 3. Well, that's a nice easy number. That's 1 unitless, right? We removed the units, which allows us to compare. Southern is what? 13 minus 16 over 2.5. So that's -3 over 2.5, or -6 over 5, which is -1.2.
I have a question.
Yes, sir.
I took my AP Calc exam last week, and Mrs. Kirsch always told us that if it's a numerical value like -3 over 2.5, you don't have to simplify it anymore. Does that go over to stats 2 or no?
Well, in this case for z-scores, what do you think the next question is going to be?
Analyze them.
Yeah. Which one is more unusual? It would be my guess.
What do
So
you
in
mean,
this case,
oh,
yeah, so I'd rather have the z-scores where I can actually compute, compare the two. So the next question, it says part B. Is it more likely that a bird of this type with a weight greater than 13 ounces lives in the northern region or the southern region? Justify your answer. So if I know that this question is wanting me to utilize z-scores for the express purpose of saying what's more likely, then I better be able to type in that z-score. Now, which one's further away from the mean? Northern or southern?
From their individual means?
Yeah.
The southern one.
And so it's going to be less likely. So one way you could justify this answer is because the z-score is further away, it's going to be less likely than the northern bird. But let's actually do the calculation. So I'll switch my screen and share with you my calculator. So this goes to how do we calculate the area under the curve? In this case, we have z-scores. So if I do distributions, I want a normal CDF. So I'm going to first do the southern bird. So I have a negative value to negative 1.2. Mean is 0, standard deviation is 1. Because
Why-
I have a z-score, I don't have to retype in the numbers. Or I could take the
Oh.
values and it would do it for me.
Okay.
So for part B, I would say using a normal model.
You wouldn't say normal CDF?
I would first justify saying both distributions are normal. So using a normal model, we can calculate the normal CDF. Does that make sense? The first
Yeah.
one, we said negative number to negative 1.2. This is for the southern region. Southern. And the probability.
Can you
that
switch your
we have
back to your notability?
Yes, I can. But I'll do the other calculation.
Yeah, I can do it too.
Cool. So the probability that we have a bird that is 13, what is it asking for actually? I should read this question. 13 ounces, greater than 13 ounces. Oh, fascinating. So I should have done negative 1.2 as the lower bound. So I'll do that really quickly. So if I instead said my lower bound was negative 1.2 and my upper bound was something big, that's like a 88, that's 13 ounces. That's what I'm asking you. What's the probability? I pick a bird at random and its weight is greater than 13 ounces. Well, in the southern region, that's 88.5%. In the northern region, the probability that we have a bird that's greater than 13 ounces is, again, normal CDF 1 to 999, because we want greater, 0 to 1. So that would be equal to, it should be 84% or 16%. Yeah, 1 minus that, roughly 16%. So if I compare these two, which one is more likely? Obviously, you would expect a bird picked at random. So I should actually justify this, right? A bird in the southern region is more likely, 88%, to weigh more than 13 ounces than in the northern region, which is about what do we say? 16%?
Yeah.
Questions on those two?
No, that was straightforward.
And most of those beginning questions will be that straightforward. Just kind of like, don't do more than you think you have to do. That's how you can get into trouble really early on.
So if it said that, like for B, if it said less than, you'd make the your z-score the lower bound?
Yeah.
Or upper, sorry.
Yeah. And that's really the part of the problem that they're looking for is, what are we actually looking for? And what's the comparison? So the key word there was greater than that weight. Good. Okay. Let us keep moving on. I've got 2 more questions that we want to do today. We'll go unit 2, which I need to pull up. Unit 2, question 1. Pull my notes back up. And I plan on doing 2 sections a day, and hopefully leave us a little time at the end of this week to kind of go over what else we should be doing this weekend, if anything. Sound good?
Yep.
Okay. So the following table shows an annual income in dollars and the amount spent on vacation in dollars for a sample of 8 families. So you got their income, how much they spent, income, how much they spend. Create a scatter plot of the data. Generally on the AP test, they'll most likely provide you with one. Just because it is painstaking to do this. Now, what would you say, Hikmat, since you're here, what's the explanatory variable and what's the response variable?
The income is your explanatory variable and your vacation is your, because your income determines your vacation.
Yes. And another good way would be to do this on the graphing calculator. So let's say, because these numbers are large, in thousands of dollars. We'll say 0, 10, 20, 30, 40, 50, 60, 70. Let's extend this out. 80, 90, 100. And then what's the largest?
It's like 98.
And then the largest amount they spend is $5,100. So I'm just gonna 1,000, 2,000, 3,000, 4,000, 5,000. Now I will say I've posted all of the solutions in that same folder if you want to check our work compared to what College Board thinks you should answer.
Mm-hmm.
So this is just, okay. 41, 1, 2,700. 41, 1, 2,700. Let's do this in red.
It can be like a rough sketch, right?
Absolutely.
Okay.
So as I do this, you can do it as well. 53, 24. 53, 24. The next one is 27, 1,700. 27, 1,700. Something like that. The next one, 34, 4, 2,500. 34, 4, 2,500. That is a lot of money to spend. 65, 8, 2,800. 65, 8. 2,800. Is that what they said? Starting to see a pattern. 98, 5,100. Must be nice to be them. There you go. That person up at the upper corner. 72, 4,200. 72, 4,200. Somewhere around there. And then 56, 70, 56, 70, and 3,200. 3,200. Of course. So something like that, right? Did I get all 1, 2, 3, 4, 5, 6, 7, 8? Got it. Got my 8 families. That's part A. Part B. Describe the association shown in the scatter plot. So this is our shape, outlier, direction, and strength. So our association between annual income and vacation spending is roughly linear, positive,
You would say, like,
Moderate
with outliers.
with, I would say no outliers.
I mean, just farther away though.
It is, but that would, this point right here. Remember, an outlier would be something that would change the direction of the line of best fit. A point that's far away in the X compared to the other values is said to be a point of leverage, because it like the pattern is following it. Okay, so as I charge, the next thing says what? Calculate the coefficient of determination and interpret the value. So what we should have done, income, that's vacation. $41, 53, 27.4, 34.4, 65,800, 98,100, 7,200. Oops, 72. And 5,6,7,0,0. Let's do vacation spending, more modest. 2,700, 2,400, 1,700. Okay, so we have our calculator. We have our values typed in. They look good. I'm going to go menu, statistics, stat calculation, and I'm going to do a linear regression. I'm going to say income is my X, vacation is my Y, frequency list 1. So okay. We get our line of best fit. We have our R squared and we have our R. It is asking us for the coefficient of determination and probably interpret it. So let's list out the coefficient of determination and interpret what that's saying. Do you remember what that coefficient of determination is?
That's R squared, right?
It is R squared.
Isn't the correlation coefficient R?
Yes, Pearson's R. So let's go back to our iPad. Charge the Apple Pencil. In the meantime, calculate the coefficient of determination, interpret the value in context. So, actually have a nice color. C, R squared equals 84.98%. We have a sentence for R squared. 80, let's just say 85% of the variability
Income.
in vacation spending.
Isn't it of the X first?
Nope. So we're looking at the variation in income spending is due to income level. So, or how much of the, it's saying how much of vacation spending can be explained by your income level. So 85% of the variability in vacation spending is due to the variability in income.
What's the difference between variability and variation?
6 of one, half dozen of the other. So the way they're looking for this answer, the coefficient of determination indicates 85% of the variation in amount spent on vacation can be explained by annual income.
Okay.
It's just saying, if we have a response variable, how much of the change or the shifts in vacation spending can we associate with the amounts of income level? which is pretty, 85% is still good. But there's 15% that's not explained by income. Okay, so that's 3 questions so far. How you feeling about these? Relatively easy?
Bad, yeah.
Not too bad.
I could do this.
I think you can too. If we want to make this a little bit faster, if you want to try some of the Unit 3 and Unit 4 questions for tomorrow, be my guest.
I have a AP Lang test on Wednesday, so obviously I won't be on Zoom, so I can try to do something after that.
Yeah, and I'll record these too in case you want them. So here we go. A random sample of 65 high school seniors was selected from all high school seniors of a certain high school. Following scatter plot shows the height and the foot length for each high school senior from the sample. The least squares regression line is shown. The computer output of the least squares regression analysis is also shown. Okay, so we've got some data. Calculate the residual. They love asking the residual question. For the high school senior with a foot length of 20 centimeters and a height of 160 centimeters. So I need you to think back, what does residual mean?
It's how far it strays away from the line of best fit, right?
Mm-hmm. So in part A, we have our line of best fit. So here's question 2. Let's do this in green. Our line of best fit, because it doesn't ask me to write it out, I'm going to write it just as y hat, is 105.08 plus 2.599 times foot length. So that's our equation. It says calculate and interpret the residual for a high school senior with a foot length of 20 centimeters. So our model would predict it'd be 105.08 plus 22.599 times 20. Which turns out to be 157.06. Just going to speed up because we have 12 minutes left. Okay, so then residual is our model minus our predicted, our actual minus predicted. Does that make sense?
Yeah.
How far off is our model from our actual data?
Wait, so it's like y minus y hat?
Yeah.
Okay.
And we can also see that if we go back here. Let's see. They don't give you in almost every single one of these. I just want to, for residual, x minus x bar, y minus y bar, x minus x bar. If you ever need a hint for what it is for a residual, it's saying how far is this point off from what we think it should be. That's all those are saying. And you're right.
Mm-hmm.
So this is what? 2.94?
Yeah.
Centimeters?
Is there a unit for residuals?
Well, this is saying how far off it is. So how far off is our model? It's off by 2.94 centimeters.
Okay.
So what would be the interpretation of this? The height senior is taller than expected based on his foot length. That's all. Or another way of saying this is our model is an undervalue. It's an underestimate. Does that make sense? It's literally lower, so it's an underestimate. You could use that word too.
Okay.
Part B, the standard deviation of the residuals is 5.9. Interpret that in context. Okay. The standard error of our standard deviation of our residuals. What does that mean? Just in general, if a residual is how far off a specific value is, then our standard deviation of our residuals says the actual heights from our seniors, how much they typically vary from our model. So the actual heights of seniors typically vary from our model by about 5.9 centimeters. The following histogram summarizes the 65 residuals. Based on your answer to, so this is a histogram for our residual plot. Oh, did I skip? I skipped a problem. C, I'm going too fast. Part C.
It says C, then under the graph, this actual question.
Assume the distribution of the residuals is approximately normal with a mean of 0 and a standard deviation of 5.9. What percent of the residuals are greater than 8 centimeters? Well, if this is a normal model, then we're looking for normal CDF. We want to be, what does it say? Greater than 8. So our lower bound would be 8. Our upper bound would be some large number. Our mean is 0. And our standard deviation is 5.9. Good with that?
Yeah. I think, yeah.
So change that. I'm just going to do this really quick. 0 and 5.9. Did you get
when?
What's that?
How do you know when to change the standard deviation and the mean for the?
Oh, I'm just
PDF?
looking at what it gave us. Our residual, our mean is at 0.
But
Our
like
standard deviation is 5.9.
on like question 1, we could have I think it was question 1 of the unit 1. Or question 2 of unit 1, we could have done that, but we left it at 0, 1. But we had a standard deviation.
That would also be like, could you find the z-score for this?
Yeah.
Our z-score would be x 8 minus 0 over 5.9. So we would get a z-score of 1.36. So if I wanted to use the standard normal model, then I would use normal CDF 8 to 999, some large number, 0, 1. Sorry, instead of 8, it would now be 1.36.
Okay.
And at any time we're using this normal model, it's always a good thing to draw in our curve. And so we are looking for this area, which turns out to be, if my calculator is to be believed, 0.0869 or roughly 9%. So 9% of the residuals are greater than 9. And then part D, based on your answer to part C, would it be surprising to randomly select high school senior from the high school with a foot length of 20 centimeters and a height greater than 165? Justify your answer.
No,
Okay,
it's not that random. Is it?
so what it's saying, would it be surprising? What do we think about surprising or unusual?
Actually, yeah, it would be random if only 9% of them are over. Or that's
So
a different.
let's just push on this a little bit. We would expect, we already did some of these calculations, right? A high school senior with a foot length of 20 centimeters is expected to be 150 centimeters tall, right?
Mhm.
We expect about 9% of all high school seniors from a high school with a foot length of 20 centimeters to be about 165 centimeters tall. If we just add 8 to that, does that make sense?
Wait, can you say that again?
Sure. So we expect from part A, um, 20 centimeter foot length, and I'm just abbreviating right now, to be 157 point what? 0.06 centimeters tall.
Mhm.
From part C, we would expect that to vary by about 8 centimeters, 9% of the time. Would you agree with that?
Yeah.
We expect 9% of all high school seniors. So not just this one, but all of them with a foot length of 20 centimeters to be at least 157.06 plus 8. That's what that 9% was for, which is 165.06 centimeters tall. 9% is not unusual. Here's another way of thinking about it. If that was your p-value, if your p-value was 0.09, would you say that's unusual or surprising?
No.
No. And that's why the answer to the justification for us is no. It's not surprising. I mean, 10% of the 9%, 10% of the time, in an easier way, you would expect someone to be about 165 centimeters tall, given that their foot length is 20 centimeters. That's not on, that's 1 out of 10. It's not that bad. It's a coin flip. So if you want to look over any of these results that we got today, because that's the end of our class, in this folder, subfolder, AP Test Practice FRQ, we have the questions and solutions to each one of those. So that takes care of our class for today. Thank you, Hikmet, for coming. I'll see you tomorrow, and we'll do units 3 and 4. Sound good?
Yeah.